All right, this will be the last part. It was cut off on the last one, so sorry for the abruptness of it. But here we have water entering a treatment facility at a rate of E of t, and it's draining out at a rate of D of t, and 12 o'clock is going to be our time 0. So the first question said, why don't you go ahead and pause after each one of these. If there were 1,000 gallons at 12, how many are there at 3? And hopefully you remember, in this case, to start with what we're given, and then we're going to integrate the rate that it's being added to see how much comes in, and then integrate the rate that it's leaving, see how much is left. And so we get something like this. Beginning amount plus how much was added minus how much was taken away. And really we should have little dt in there on each of those. All right. Next question, at what rate is the volume changing at 215? And a little helpful reminder that means that's t equal 2.25. Go ahead and see if you can tell me when that would be. All right, and the rate that our water is changing is just basically two rates, right? It's the rate that it's coming in and the rate that it's leaving. So it would be E of 2.25, that's how fast it's coming in, minus D of 2.25, how fast it's leaving. At what time is the volume of the water neither increasing or decreasing? Go ahead and try that. And we would have no change in our volume if the rate that it was coming in was the same as the rate it was leaving. So hopefully you wrote that. All right, last time. Can you write an equation for time A when the tank is empty? I'll give you a second to try that. So for this one, it's similar to the first one, except that saying we're ending at 3 o'clock, now we're saying we're ending at some time A. So we want to know when was 1,000 gallons plus the amount that has come in, E of t dt, minus the rate that has the amount that's left. When is this volume equal to 0? So that's our equation there. So if you had that, nice job. You could see something generic like this. Again, I don't know if they're going to have you using, they've said that the test does not need a calculator, but you can use one. So they're not going to give you something to integrate into your calculator this year. But this might very well be something that they ask you to do, just generic stuff like that. Writing a differential equation, this says the rate that a population changes is proportional to the square of the population. So see if you can write a quick little differential equation for that. And the rate of a population change is change in population over change in time. And this proportional means we have to have some type of constant to keep these two sides balanced. And it's proportional to the square of the population. So we're going to multiply by p squared. So simple enough. Hopefully you remembered that k. Would they ask you to do this year? My guess is no, but you never know, right? So just in case, we cover it here. Slope fields. I don't think they're going to ask you to make a slope field because that would take a lot of time, and they really don't have time this year to work on it. So I think that they may give you a slope field and have you work on it or whatnot. But if you were to make a slope field here, take a second. Where would your horizontal slopes be and where would your vertical slopes be? And we're going to have horizontal slope when our derivative is equal to 0. And so that's when the top equals 0. So when x plus 3 equals 0, which is when x equals negative 3. So all along the line x equal negative 3 right here, you would have 0 slopes going down that. For our vertical slope, it's when dy dx is undefined. And that would be when the bottom is 0, right? When 2y equals 0. So that's at y equals 0. So all along the x-axis, actually, you would have vertical marks there. And then at this spot right here where they intersect, you would have nothing because it would be 0 over 0, which won't generate a slope for us at all. Everywhere else, you're either going to have a positive or negative, and then you'd have to make a decision, and the AP usually would grade you. They would look for these values first, and then for your positive negatives. Right? Now, using the same equation, can you find the second derivative for that? I'll give you a moment to try that. All right, and our second derivative, we're going to take the derivative of this using quotient rule. So the second derivative here would be bottom 2y times derivative of the top, which is 1. So I'll just leave it like that, minus top times derivative of the bottom, which will be 2 times dy dx, over bottom squared. And if you want to write that as 4y squared, that's fine. But this would be our second derivative to start with, but that's not where you want to finish, because what you want to do now is take that dy dx and put it in. So our second derivative will be 2y minus x plus 3 times 2 times x plus 3 over 2y over 2y squared. And that's where you want to stop. So they may give you a point for the quotient rule and a point for plugging it back in if they asked you to do something like this. It's hard to say again, like what they're going to really ask you. But do remember quotient rule for sure, but then remember in a case like this to plug that back in. All right, the last thing we're going to do is the separation of variables and find a specific solution. So this is the one thing you had to kind of do on your own. This was right after the whole thing went down with COVID-19. So first thing you want to do is separate, bring the 2y over, bring the dx over. We'll have 2y dy equals x plus 3 times dx. They usually give you a point for doing something like that. Then you want to integrate both sides. This is going to go to y squared equals x squared over 2 plus 3x plus c. They'll give you a point for the integration. Then we want to figure out what c is, so we're going to put these in. So negative 3 squared is 9. 2 squared divided by 2 is 2. 3 times 2 is 6. So I end up with c equal to 1. They'd give you a point for that. And then the last thing you want to do is plug that in and see what the y would have to be. This is on the easier side of problems that they give, but who knows? Maybe this is something they do. In this case here, we're going to have the square root of this. Now in that, because it's square root, it's technically positive or negative, but because this is a specific solution, you have to decide which one it is. So what I would say is put the 2 in, 2 squared over 2 plus this. This gives us 9. Square root of 9 is 3, but we want negative 3, so we need a negative right there. That would be our specific answer. Okay. So hopefully that's helped you and you feel like you've gotten a good glimpse of everything. Make your note sheet be something useful, productive. Don't put every God blessed thing on there. You'll never be able to find what you need. Only make it be the things that really are important to you. But I know you're going to do great. Good luck and do your best.